In the last video, we have seen that we are trying to call this get data method polymorphically from the save method of drawing class using the save pointer, but it is still calling the base class function get data and not the direct class function. So what should we do? First of all, the thing that we have done here is actually the object is not allocated dynamically. It's still on the stack and we are actually storing its address. We're trying to make it full, but the virtual table is not populated properly. So instead of doing that, I'll be taking pointer itself directly here and I'll be storing the save pointer on the saves. Now if I try to build it, now error will come from this side. So what I will do, I will try to store the address here. So will it solve? Let's see. When I'm trying to achieve polymorphism, let's see, it is now pointed to the pointing to the point class get data method, and we are able to call it polymorphically and we got the data. Now, did we really done any um, polymorphism here? It seems it is polymorphism, but here we have not actually created the object dynamically on heap, right? It still actually seems to achieve the polymorphism. If you are happy at this stage, well and good, no problem. But normally we can do something like that. We can create the pointer of the point class like this. We can simply pass this to thing. And at this stage, line AB is still taking actually the object of A and object of point class. You can pass the address of, no, sorry, it work. It is supposed to work. Hitting the data probably. Yes, with the correct data. When we are taking the point as pointer, we can also take it point from line, right? And at this stage, we have to write new line. So far, so good. Works. When I delete, it will populate the data. Now, if we are doing with pointers, let's make it explicitly pointer here also, and we'll be also taking pointer here, right? So what is the problem? The problem is here. Now we don't need this asterisk here. All is now pointer based. What is the problem? Yeah, we have to actually change it to arrow, as start is now a pointer and not object. Now we have achieved this, and I guess it's a proper polymorphism in action. As you see, with a single call, we can. So this get data is a polymorphic call. Sometimes it calls the point get data, sometimes it's called the line get data, depending upon actually exactly address of what object, what kind of object is stored, right? Now we can actually directly do this here, something like that. It will write to the file as it's a single line under the for loop. We can just do that. So it's very small code, right? Open the file, dump the data by iterating the list of steps, and then close the file. You got the data here. Whatever the format you want, you will get it by overriding the corresponding method of line and point. So if you find any problem in this implementation, or if you think there is better approach of achieving this, you can comment in the video section, comment section of this video. Also, we have seen that we actually don't need so much pointers. We can simply achieve the polymorphic behavior without so much pointers. But you often see this kind of code in CAD API. So it's better to have accustomed with such coding, right? So here also you can do it like something like that, exactly same like the above. It's actually overkill, but yeah, you often see this kind of code. But this is not necessary to dump the data polymorphically. We have achieved this even without using pointers at this level. Use pointers only when necessary, but you should know where it is required and where it is not required. Okay, so I think this is enough for this video. We'll stop here, and I will think in next video what we can learn.